So now we have some examples with applications for graphing. So I didn't provide a graph grid here that we've been using to graph lines because these situations are a little bit different. So we'll show you how that works. And so we'll read the example. Number 8, the equation h equals 2s plus 50 is used to estimate a woman's height in inches, h. So this is a woman's height based on her shoe size, s. So the s is the shoe size. Now, they have to tell you what the variables mean. So we're not expected just to know what h and s mean without some information. So it says, A, estimate the height of a child who wears women's shoe size 0. So if the shoe size is 0, so so this is part A. If s equals 0, then you have h equals 2 times 0 plus 50. So h equals 50. So you're saying, well, we think the child is 50 inches tall. Okay, so part B. Estimate the height of a woman with shoe size 8. Okay, so now we know the shoe size, S, is 8. So we'll say h is equal to 2 times 8 plus 50. So you do the calculations, h equals 16 plus 50, h equals 66. So 66 inches. So if you have a size 8 shoe, then maybe if you're a woman, maybe you're 66 inches tall or around that. Okay, part C. Interpret the slope and H-intercept of the equation. So notice they say H-intercept instead of Y-intercept. So the H-intercept is going to say, that's if size 0 for the shoes is 50 inches. So you're not going to have less than a size 0 in women's shoes. So the minimum height that we're talking about if you're going to wear women's shoes is going to be 50 inches. That's the estimation. The slope is 2. So we're saying, well, or 2 over 1. So for every shoe size you go up, your height should go up 2 inches. So this is your inches, and this is your shoe size. So for every shoe size you gain, then you should have grown 2 inches. That's the interpretation. Okay. Might not be true, but that's the interpretation. D, graph the equation. So to graph it, I'm not going to have a negative shoe size, and I'm not going to have a negative height. So I just need the first quadrant, really. Okay, so maybe I want to do shoe sizes. So this is going to be my s-axis. That's tricky to say. And then this is going to be my height this way. So maybe my shoe size, I want to go 1, 2, 3, 4, 5, 6, 7, 8, because I went up to 8, so I might as well do that. And then my height, I think I'll count in tens. So 10, 20, 30, 40, 50, 60, 70. So I'm going to say this is 60 inches. So a lot of times we like to label this inches. They'll write it like in parentheses, so you know that's inches. And down here you could say, well, this is the shoe size or something like that. Try to make a nice graph, because your graph needs to have some meaning to it. Okay, now we have all the information we need to graph. We know that we're starting when the size is 0, that you're at 50 inches, right? And then at size 8, I think that was way over here, it's up like to 66 inches, something like that. You could say, well, I know I'm going up 2 inches for every shoe size. You could do like a slope thing here. Well, that's not drawn very well. It'd be better on graph paper, but you just need that first quadrant, so you kind of have to change your grid a little bit. But it's something like that. Okay, I think we have another example. Stella has a home business selling gourmet pizzas. The equation C equals 4P plus 25 models the relation between her weekly cost C in dollars and the number of pizzas P that she sells. Okay, so this is the number of pizzas. P is the number of pizzas she sells. The number of pizzas sold. And C is her cost for the week. Okay. A, find Stella's cost for a week when she sells no pizzas. Okay, so for part A, we're going to take our equation. And we're saying she doesn't sell any pizzas, so P is equal to 0. So her cost is going to be $25 no matter what for the electricity or whatever. Cost her $25 or advertising or something. Okay, part B. I guess we should say cost is $25 and she doesn't sell any pizzas. Okay, part B. Find the cost for a week when she sells 15 pizzas. So cost is going to equal 4 times 15 plus 25. So the cost is going to be 60 plus 25, or the cost for the week is going to be $85. Okay, so she sells 15 pizzas. Interpret the slope and the C-intercept of the equation. Okay, so let's see. If she doesn't, so her intercept, her C-intercept, that's her just flat cost. It's not based on how many pizzas she sells. So even if she doesn't sell any pizzas, she's going to have a cost of $25, no matter what. Call those fixed costs. So her fixed costs are $25. Now, the slope, that's saying for every pizza she sells, she's got to put $4 into the ingredients. So $4 per pizza for the ingredients. Okay? And that's what that's costing her. It's costing her $4 per pizza to make one. She makes 2 pizzas and she's going to have to invest $8 probably for the ingredients. Okay. And D, graph the equation. So again, I'll try to do a better graph here, but we've got a graph where we're just having a positive number of pizzas and a positive cost, right? So, okay. And they want us to graph it. So we know the slope is 25. So let's see, let's count by tens again. 10, 20, 30, 40, 50, 60, 70, 80, 90. And then number of pizzas that we're selling. Well, at one point we sold 15 pizzas. So this is my number of pizzas that I'm making and selling. And then this is my cost up here. Okay. And you could write something like number of pizzas sold. And then you could write cost over here someplace. Okay, in dollars. Okay, so let's go 5, 10, 15, 20. So let's label these 20. Now we're counting by 5s there. And then we were labeling these by 10s. 20, 40. You have to put some numbers so that people will know what your scale is, okay? And so it costs $25 no matter, if we sell 0 pizzas, it's still costing $25. So that's my y-intercept, $25, 0, 25, that point. And then when I sold 15 pizzas, it was costing $85. So 40, 50, 60, 70, 85. So it's going to be like right here. I'm trying to draw a little dotted line here. And then the 15 is going to be like right there. And then my graph is going to look something like this. Now, on the last one, I don't know if I put my line. Yeah, I shouldn't have put my line in the negative part. I should take that part out. You can't see it anyway, but because we're not going to have a negative number of pizzas that we're going to sell, so it really doesn't go in the other direction. really only goes in the one direction. Okay, so there's the graph, and just trying to show you that we can apply these things in some business models and how that works.